please welcome Neil Hanlon.
Thanks so much for having me. Thank you for the warm introduction. I grew up on the North Shore, Massachusetts. So Boston, I went to school here. Really happy to be welcomed here in this space. So I'll talk to you a little bit about Python and Rocky Linux. It's a lot, I think, less about Rocky Linux per se and more about all of the Python that goes into building an RPM-based distribution of Linux. So I'm calling it a love story in 3 parts. Who am I? I am one of the Rocky Linux co-founders and infrastructure leads. Talk about what Rocky Linux is and why it needed to be co-founded in a little bit. I work at CIQ in their open source program office. I primarily focus on the Rocky Linux community and its infrastructure, trying to do the best it can be to serve out the values that we've set forth for the project and the organization that houses that project. I'm also a Fedora and Apple packager and contributor. Apple is extra packages for Enterprise Linux. It's an add-on repository that gives you back some of the packages of Fedora that are stripped out by Red Hat because they're trying to limit the scope of support that they're giving. I contribute to OpenStack Ansible, Medicine Society. You can read the rest. Never killed myself while doing electrical work, so got that going. What is Rocky Linux? You might ask me. What the heck is Rocky Linux? Rocky Linux was founded in December 2020 in response to the CentOS project's shift in focus from CentOS Linux to CentOS Stream Linux. CentOS Linux used to be a community rebuild of Red Hat Enterprise Linux, which is the commercial distribution that Red Hat builds and sells to their customers with support and services and the gambit of all the fun things that you want to do to make a business around open source. And Red Hat has done a fantastic job of that for the past 25 years and so, right? So CentOS Stream was a rebuild of that with all of the features and great things you get from a corporation with a lot of employees working in open source and contributing back and doing testing and regression testing and quality assurance and everything else on a distribution. And in 2020, they shifted focus from CentOS Linux to CentOS Stream Linux, which instead of tracking ahead or behind Red Hat and rebuilding those sources, was now the development environment for what would become the next minor release of Red Hat Enterprise Linux. So at the same time they did this, the EOL for CentOS Linux had changed to, instead of being, CentOS Linux 8, let me be clear, changed from having expired in 2029 to rather expiring at the end of January of 2020. Yes, words. So it was cut short by like a little over 5 years of support that folks thought that they were going to have for the distribution that they had come to know and love in CentOS. But learned CentOS in school, and it's how I kind of got my start into Linux in general and the job that I have. So RHEL is widely used in the industry for mission-critical applications and services. It supports architectures like x86, 64, and ARM, but it also supports PowerPC and S390X, because people still run mainframes, it turns out. Who knew? Rocky exists to fill that gap, right? So now that the CentOS project is focusing on CentOS Stream as an upstream for what will become Red Hat Enterprise Linux, there is a void, a vacuum, and many, many things dropped into place to fill that void. Rocky Linux was one of them. So I have here, our kind of mission statement. We're a community-driven enterprise Linux distribution, stable enough for the largest enterprise to rely on, community-driven to ensure it stays accessible to all. That was one of the big things that we found while building Rocky Linux from the ground up. A lot of the tooling in creating the distribution, not just building the packages and putting source and running make and blah blah blah, but composing all of that together into the repositories and the structure and everything else that is expected by customers, and then also delivering it to all of those users in a redundant, reliable, globally accessible way.
So what is Enterprise Linux? I have a graph up here. Hopefully it's big enough. This is looking at specifically CentOS or Enterprise Linux 8. It is branched off of Fedora 28. Every 3 years, essentially, Red Hat is now releasing a new major version of the operating system, and it will branch off of a version of Fedora similar to this. This is kind of the most complicated graph that we can describe here because it describes the transition of when CentOS 8, CentOS Linux 8, and CentOS Stream Linux 8 both existed as a upstream and downstream of Red Hat Enterprise Linux. So you can kind of see RHEL goes along and has minor releases. CentOS used to take from those and build them, and then now CentOS Stream, which was introduced with 8, is ahead of RHEL such that it becomes the next version. So I mentioned CentOS Linux 8 was EOL'd early, and the focus was shifted to CentOS Stream. CentOS and Enterprise Linux in general is generally just a minimal subset of the packages contained inside Fedora Linux. Fedora has packages from all over the place. You can add them pretty much without, as long as it's an OSI approved license and you can build it and it follows the guidelines for Fedora, you can add it into Fedora. But that doesn't necessarily mean that Red Hat and other enterprises want to provide support for that package for 10 years. And locked on that version for 10 years as well. So there's a lot of decisions made by Red Hat engineering in the creation of Enterprise Linux that limits the scope down to a very minimal subset. I mentioned new releases happen about every 3 years, which is about 6 Fedora releases. It used to be 5 years. It used to be a lot more change than it is now. But there's still a significant amount of change that can happen in 6 Fedora releases. Lots of software changes, versions change, software is archived or abandoned. There's a lot of movement, I think, in the distribution space, especially a distribution like Fedora, that can influence what happens in Enterprise Linux. Each major release of Enterprise Linux is supported for 10 years. The first half has full support. They're still going to be pinned, more or less, to the versions that are branched from Fedora in this case, but the first half of that gives Red Hat the ability to adapt to changes in upstream software, where there might be just some software released version 4, let's say, and Red Hat had picked version 3. There's some flexibility in the first half of the support cycle for rebases to new versions of software such that it'll make their life and the life of all of their customers a little bit easier for the long run. And then the second half of that support, the last 5 years of the 10 years of Enterprise Linux lifecycle, that becomes maintenance support. And that's the point also where CentOS Stream Linux becomes EOL. So CentOS Stream has only a 5-year lifecycle compared to the 10 years that is offered in RHEL and downstream rebuilds. We also leverage community-supported add-on repositories often in Enterprise Linux because it's such a minimal subset of what is offered in Fedora. A lot of actually RHEL customers, anecdotally rather, don't consider RHEL to be a fully baked product that they can use and install in their systems unless they have access to EPEL. Unless they have access to Fedora packagers, volunteers mostly, who choose and decide to branch and maintain software in EPEL for the long-term use in this. So, Python. Let's move into kind of part 1. In any modern Linux OS distribution, whatever, you're going to find a lot of software written in a myriad of languages. Off the top of my head, in Red Hat, there's Rust, Java, C, C++, Python, Ruby, Node.js, lots of Bash, probably, and way more. I mean, RHEL and Fedora have GHC and Haskell and a whole gambit of fun things that are not really fun to compile together. And decisions were made in the past 7-ish years while building RHEL to try and make customers happy that have made the maintenance of these systems a lot harder. Python, though, is kind of a core component, really, of the entire operating system. The distribution itself is based in RPM. RPM is C and Python libs, or bindings. And there's a number of components, no particular order here, that make up a core part of the operating system that are entirely or mostly in Python. Got platform Python, which I'll discuss a little bit. It's just Python, don't worry. Needs to be distinguished, though. DNF and RPM are both C, C++, and Python, largely. C for performance reasons. There's history there. Anaconda, no, not that Anaconda. Anaconda, which is the installer for Fedora and Red Hat-based distributions. And then Cockpit Project, which is... it's a graphical interface. I didn't put a picture here, I probably should have, but it's a web UI for servers. So it's like Webmin, but less worse. It manages all your storage, networking, logs, containers, VMs, etc. It, of course, being a web UI, has a nice smattering of JavaScript and NPM dependencies and whatever other fun things web developers are doing these days. But largely, this project is Python and makes a significant impact on the usage and administration of Red Hat and Fedora, but also Debian and Ubuntu systems. Another one of Rocky's sponsors or partners is 45 Drives. They contribute a lot to the Cockpit project in various add-ons and additional features that they bring to enable the specific storage type operations that they're doing. And so that's been a really great story of upstream collaboration in this project as well. Anaconda is, as I said, the installation program for Fedora. Has a GUI, VNC or TUI. It uses kickstart files for unintended installs. This is similar to Ubuntu Debian's precedes, where you can have like an answer file that tells the system how to install itself. Uses GTK Builder and Glade for customization. This is like really, really long in the tooth at this point, and is being replaced in newer versions of Fedora, which will then trickle down into Red Hat and Rocky and etc. With a new modern UI that doesn't suck. There's also Blivit, which is a storage library, and a bunch of add-ons. I think one of the obvious patterns here is that a lot of software that was written in RHEL 20 years ago, like Anaconda, has grown over time and split out into lots of other components for a number of reasons, mostly performance related, but also just because, stuff changes, it grows over time. DNF is a really good example of that. DNF's the package manager for Fedora, RHEL, OpenSUSE, and others. DNF is Dan-defined yum. There's really no reason that it's called Dan-defined yum. I found this out recently, actually. It was just a name. They're like, we'll choose 3 letters, and it was DNF. DNF is a rewrite of Yum, Yellow Dog Update Manager, which is itself a rewrite of the Yellow Dog Updater, or YUP. It's just a layer on top of RPM, which handles the interdependencies between different RPM packages and really rich language to describe packages that recommend, require, or need to install alongside other ones. DNF4 came about in about 2013, and it's Python and C-ish. DNF 1 through 3 happened so quickly that they don't actually exist. We don't talk about them. DNF 5 started in about 2018. It was a full rewrite in C++. It was originally starting out to be a breaking change, like a version that would have a new interface and people would have to learn how to use it and everything else. And over the past couple of years has now turned into a replacement of the existing software with most of the same issues, some of them fixed. We'll see what the future holds. As I mentioned, that's only in Fedora right now. It's gone through a bunch of different changes, and they've tried to get it into the main distribution, and it's been pushed out because it's not working right, and it's much better than it is now. A whole lot of effort has gone into it from Red Hat, which I'm extremely thankful for because it is so much faster than the existing tooling, even though it has a lot of the same issues. Let's discuss, I think, DNF4 a bit, because that's more related to the Rocky and enterprise Linux side of things at this point. Explain some of the history. A lot of it's really dry. Like, there's threads on every website I'm sure you can think of about why this has happened in Fedora and all of the development. That's one of the good things, one of many good things about the development that happens for Fedora is that it is all in the open. You can go and read about all of the things. But the significant driver for DNF over Yum was memory usage. Prior to DNF4 specifically, all of the logic for depth solving was handled right inside the tool and in Python, like just Python. And it turns out that satisfiability algorithms are not really well optimized to write in raw Python. So one of the cool things that came out of this was libsolve, which is a cross-distro method for satisfiability, which is baked into and used by RPM and DNF and a number of other tools that are related to the building and maintenance of that. There's also libdnf, which is kind of the high-level DNF API with Python bindings. Librepo, which is, it's basically libcurl, but with other things to handle RPM data. It's fairly straightforward, and it just calls out to curl. And libcomps is sort of interesting. Fedora has an idea of comps, which are groups of packages that you can install or select to be installed either via your Kickstart file for unattended installations or via the GUI while you're going in, and you can select, I want it to be a minimal server with virtualization and storage and debugging tool or something. So there's this rewrite of libcomps, which is used because, again, pattern. Writing it in a different language or just rewriting it is the Python 2.3 thing kind of reinforced rewriting a lot of these things just from scratch and taking time to think about how they should be done rather than just replacing them with the exact same thing that they had was one of the best parts of this. So, platform Python. The DNF and RPM kind of need Python, it turns out, because they're written in it. So Yum and DNF was a weird transition point in Python 2 and 3 where it was like partially it was partially backported to Python 3 for some versions of Fedora and Red Hat, not at all for others, and so we had this kind of weird mismatch of what was going on. But ultimately, they landed on this thing called platform Python, which is the system Python in RHEL likes at this point, or Fedora likes really. And this is installed by just like the Python 3 package. So if you install Python 3, you're going to get, it's going to be installed because you need it for a working system, but it will provide this binary that can be used. As far as versions, Rocky 8 has Python 3.6.8, and Rocky 9 has 3.9.18 as the default versions that are available. A couple of pitfalls. Tools like Ansible can get confused because not all of the packages in Red Hat are compiled and built for all of the versions of Python. Most of the things are only built for platform Python. So additional libraries and modules from PyPy or whatever else end up getting essentially lost in the shuffle because there's too many to do, which I'll touch on a bit upon later. RPM modularity is what really exacerbates that and turns too many people using pip just to install, which is fine, but it's not what we as distro maintainers want. For better or worse, probably a holy war, but many just end up using pip, and it's not the perfect solution. It's not what we want to see, but there's really no better way to do it. So the experience of using and developing Python on Rocky Linux, how hard is it really to get started? Well, it depends, like most things. There are hurdles, like non-standard repositories like EPEL and RPM Fusion, or just having to use pip and installing from PyPy. There's a lot of tools that can help find what you're looking for. So packages.org is a really great tool that has not just Enterprise Linux and Fedora and blah, 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 but every Linux distribution. And if you're looking for a package, or if like a Python module is available for a particular distribution, that's one of the really great places to look. You can also support them on Ko-fi or something. I forget. One of the things. They're just a guy from the Ukraine, so support them. RPMs isn't hard, but again, pip is probably going to be your best bet for most developing on Rocky Linux things. A little bit of a closer look. I know we haven't talked about what modularity is, but Rocky 8 has both modular and non-modular versions of Python. The platform Python is required, and it's the non-modular version for DNF and most system functions to work. Most packages, like I said, are built only against like the default Python, or if you're lucky, a couple of the streams might be built, module streams might be built for them. But in general, modularity was not implemented correctly for Python in Rocky 8 and Rel 8. And because of that, they sort of just skipped it completely in Rocky 9. And instead of having module Python or Python modular Python, they just have Python and have multiple versions of it that you can install. It's essentially word soup at this point because everything is a module. Modularity. It is always possible to agglutinate multiple separate problems into a single complex interdependent solution. In most cases, this is a bad idea. So modularity, RPM modularity, to be specific, was introduced to address the growing complexity and diversity of software requirements in modern environments, enterprise or not. It aims to be a way to customize and manage different versions of software within the same distribution, but allowing the users to combine the different modules kind of as they see fit, making a more or less composable operating system. Seems like a really good idea, but it was fraught with peril from the start. Some really quick backstory. So in the beginning, we used to all just kind of manage our systems like, they were in our garden. We can't do that anymore. Like, we don't have long development cycles anymore. We don't have systems that we can maintain like, pets. I'm talking around the cattle and pets analogy because I don't really like it. Enterprise Linux releases are supported for 10 years, but we get this vicious cycle of needing the latest and greatest softwares for everything, but not actually being able to support that for the life cycle that is required for business continuity in a lot of cases. Containers are sort of a solution, but they're also not. Like, the conversation ends up coming around to, if you're just creating a distribution to run a container, why not just use any of the other container distributions out there? Like, and if you're running a container, you're probably just running like Alpine Linux, and you're negating a lot of the benefits that you're supposedly offering as an enterprise distribution of Linux. The idea of modularity was great. However, the horizontal the way they chose to implement it in allowing users to compose any part of it just made a multiplicatively worse issue in testing, validating, building, bootstrapping, all of these sorts of things, because it's not really even possible to show a graph of it. This is stolen from a presentation. sort of the idea of modularity, but if you were to look at a digraph of what modularity did to the build cycles in Linux or Fedora Linux and Enterprise Linux specifically, it just like you'd need a plotter or two to print it. So we're doomed. Well, yes, but maybe not. We face a lot of challenges in packaging all of the software. Like, it's not really tenable to package every single piece of Python and every single Rust package and every single Golang package, and it's just not really possible. There have been a lot of interesting approaches to solving that. One of them, or the biggest one, especially for like Golang and Rust, is just vendoring and bundling vendored libraries. Not the greatest thing in the world, but it's a good stopgap. And we can maintain the important stuff. The software development velocity isn't going to slow down. Like, it's probably only going to speed up, and we can only really go so fast as humans. I'm not going to talk about AI because James will probably kick me out, and I don't want to. But what we can really do, aside from maintaining those important packages, the things that DNF and RPM rely on, is focus on improving the tooling. Specifically the tooling to help reduce the iterative cycles that are required to build an RPM package from a Python package, say. And some of this work, not for Python, but for other language ecosystems, has been implemented in Fedora and has really helped enable getting packages and software available to users that want to use it without them having to use a packaging system that isn't the one that they prefer, which would be RPM in this case. Part 3, Empanadas. So all of the tools that we use in Rocky are heavily influenced by Fedoras. A lot of the Fedora tooling is written in Python, it turns out. I personally put this towards the versatility and approachability of Python. Initially, we in the Rocky project started leveraging the Fedora tools, like Koji, Mock, Module Build System, Punji, and Lorax. These are all things that Python has developed over the past 20 or so years to build and compose Fedora Linux and Red Hat Enterprise Linux and all of the rest of them. Punji does some depth solving stuff and makes composes out of all of the packages. Lorax speaks for the trees. It builds ISOs, essentially. So there's a lot of domain knowledge and really specifically programmed and business logic encoded software that works really well for Fedora that has been using it for so long, but doesn't necessarily work so well for everyone else. Initially, we tried to solve this by writing a thing called distro build. It's a wrapper around Koji and MBS. Koji is the build system for Fedora Linux. It works alongside Module Build System, or MBS, which is what does modularity. It is able to keep track of the module metadata and submit builds to Koji in the correct order and keep them around such that you can build, 50 different Python modules that all have unique dependency cycles inside of them. And we needed some way to solve for some of that. So we wrote this thing called distro build. It's in Python. It's essentially just like a fancy wrapper to call some APIs, but it does a good job. That led into something we wrote called PV2, which is part of our second generation of our build system we call Paradot. We are also the problem. Like, in our quest to rewrite our build system called Paradot and improve things, we initially kind of wanted to rewrite it in Python. We wanted to write it in a language that more of the folks involved in our project were familiar with or at least had exposure to, but ran into a lot of the same issues that we saw and knew about in the Fedora tooling, along with scaling and anyone can write Python, but not everyone should. That being said, we still have a lot of tools that we have that are in Python. Our errata publisher, it's called Apollo. It needs some help if you're interested in that sort of thing. But it's in Python. It attempts to do some stuff. I'm not sure what the future of it's going to be. But we do have a lot of tooling around our build system, which is now Go and I think Rust. We'll see how that goes. But there's a lot of tooling that's used by Fedora that we are still using today. Like, we're still using Koji and MBS and distro build. We technically maintain distro build as like an archive, sort of fixes only going to happen to it, as we're focusing now on Paradot. But a lot of this is still a work in progress for us, but there's a tremendous amount of holes in the release engineering experience for Rocky Linux, at least, that have Python, those holes are Python shaped. And one of those is our release engineering and image building toolkit. And that's Empanadas. So it started as a bunch of bash scripts, and it still sort of is a bunch of bash scripts, but it's also a bunch of Python code. I called it Empanadas because I don't remember, but it seems like a good idea, and we created a fun logo for it. It seems to make sense because we're like making nice little delicious packages of something, but uses click, RPM, Python, which is like the bindings to manipulate and investigate RPMs. Way too much subprocess.run, and it's under continuous refactoring efforts. The most recent thing that I merged into there is a refactor of our image building code to be modular and not modular, to support multiple backends for building instead of being tied to a single backend that we were no longer going to work on. So that was kind of I hadn't done a lot of Python code in a while, and that was a fun experience to go and write some interface-like classes to help make my life a little bit easier. You can check it out there at SIGcore Toolkit. There's a bunch of stuff in there. Empanadas itself is in the ISO folder. One of the refactoring things that I need to do is actually come up with a project structure for that thing. And friends. So we use a ton of Fedora tooling still, besides Koji and MBS and the like. Mirror Manager is one of the core pieces of our distribution method for Rocky Linux. It's mostly Python, but also Rust. Again, it's one of those patterns we keep seeing where there's things written in Python, and then it turns out that when you have millions of systems connecting to them a day, it doesn't scale well to do a lot of operations in single-threaded Python. And Rust, for better or worse, has been the solution for a lot of the things in Mirror Manager land. But the GUI, or the UI for it, I guess, is still fully in Python, and that has helped, I think, the project get more developers and users that wouldn't otherwise be interested in playing with the project. It had a bit of a resurgence in the past 3 years of work to get it actually working on Python 3, and updating a lot of the code so that it's not ancient Flask. The other things are Mailman and HyperKitty, which are a blessing and a curse. Inside the Rocky project, we don't actually use mailing lists a whole lot. We have a discourse forum that gets a lot more use, but we have a number of folks in our community that, dare I say, demand a listserv experience, and Mailman and HyperKitty are the tools to use for that job. Kiwi is something from OpenSUSE that is a really, really great image building tool. I don't know how well it works for things that aren't RPM based, but it is the basis of all of that refactoring that I had just done in Empanadas was to enable us to build build images using Kiwi instead of using Image Factory, which was a whole nother mess of Python that I'd rather not get into, to build images using KVM and libguestfs and a whole lot of stuff. And there's definitely things I've forgotten. these are certainly the main upstream Python projects that we rely on for our community. So, what does this all mean? Python plays a fundamental role in Fedora, CentOS, Rocky Linux, all of that ecosystem. Not just in the distributions, but in the processes involved in building them. Fedora uses all of these tools and is going to continue to use them. They're not chickening out like we are. They're still using them and writing them, and that's great. The approachability for Python makes that awesome for sysadmin adjacents. Even if they aren't writing Pythonic code, even if it needs to be refactored in 15 years when someone figures out that it's not a good idea to write statusability in Python, it's still something that they can look at and read and get things done. And I think that's what we've really seen in the past decade or so of the change from having a backyard farm to this industrialized, or a backyard garden to this industrialized farm that we run across multiple clouds, and we want them all to communicate, and we never want them to be down because we don't want to get paged in the middle of the night. We've solved a lot of these problems, and we continue to solve them over and over and over again. RC 1925, which I've referenced a few times here, is answers to challenging questions even when they're not related to networking. You can just replace networking in all of RC 1925 with just engineering generally, and it all rings true. The only thing I think, and this was spawned by a conversation I had earlier today, it's okay to let people repeat mistakes. Because it's true that the only way, if you don't learn from history, you're doomed to repeat it, right? But even RC 1925 says this too. But sometimes you really just have to live through something. You have to do it before you can actually understand why it's a bad idea. And so giving room for failure and for that sort of learning is tremendously important. Thank you.
Yeah, thanks very much, Neil. It's a very informative talk. Questions?
You did make reference in passing several times to modular Python, which is two words. I know what both of them mean. I'm not sure what they mean when put together.
Yes. I can show you. Can I show you? Maybe. Oh, that's 9. That's still 9. I can't type.
If this is a problem,
No.
we just disconnect it.
No, we good. It'd help if I had Wi-Fi. I even had my hotspot on. It should have just worked. Is that the Rocky Linux one?
Dangerous words there. It should have just worked.
It should just work. It should just work. So modular Python. The modularity thing was an attempt to allow for multiple versions of software to be built and available for usage. So I'll use PostgreSQL as an example because it's implemented the correct way as a module. Postgres, 10, 13, 15, whatever, 12, 13, 15. All 4 of those are available in Rocky Linux 8 as versions of PostgreSQL that you can switch to. So you can say, by default, I think it's on 10, but you can say DNF module switch to PostgreSQL 12. And then if you just upgrade or install PostgreSQL, that will be the version that you are installing. So it allows you to kind of say, this system is doing this function and it needs a newer version of PostgreSQL or Node.js or Python. The thing they did with Python was, instead of having a single Python module with each individual version being a stream inside that module, is what the terminology they have. They did it so that each Python version had its own module stream entirely. So instead of doing module enable Python and then telling it the version of Python, you're saying, or we now say for version 8, like enable the module called Python 3.8 or Python 3.11, instead of enabling the module called Python with the stream version of 3.11 or whatever it might be. It was a really good idea. It's just the way it was implemented, specifically around the build system, like Koji and module build system being separate components that have to work together to build a module, is just wild. Like, the build system itself has no understanding of what a module is. It just knows how to build an RPM. And so you have to have this external software that feeds it not just the right RPM to build, but saving all of them in the right order, because you might have like 10 different steps of how you have to build this, because there's different rings of like a Python. Building Python, for example, like there's a bunch of core components that you need before you can build the next ring, before you can build the next ring, and then you have to do that every time you're updating any piece of that software, times every stream. And you're supposed to be able to test all of that too, but not just test it, test every combination that a user might select. Python made it hard too, because all of those different modules were able to be installed simultaneously. So you could have, like, I could install a system with like 7 different Python versions just from RPM, and then like install others with whatever else I want to install Python with. So it made a really, really big mess in Python that hasn't been fully sorted in the operating system. Like the Ansible thing is actually a really, really big deal for folks, because they've flip-flopped back and forth on which version of Python Ansible will be tied to on the system. Like they initially were going forward with it for Rocky 8, or for RHEL 8 rather, and I think 2 or 3 releases ago they were like, we're just going to go back actually. So they had gone forward, and people had rebuilt their own internal Python packages and everything else against this new version, and they're like, actually we're going to stick on something else. So it's been a big roller coaster, and people are not super happy about it in particular. But it really goes back to the fact that Python is such a core piece of the distribution that like you can't just install Python 3.11, because DNF and RPM and everything else are expecting it to be 3.9.18, and it's going to be 3.9.18 for 10 years.
So is it fair to characterize the modules as me giving away? I haven't used Fedora in a very long time.
Well, modules aren't in Fedora anymore, so they got rid of them.
Right. Well, it's getting away from like this is the system version of the package. Like on a Debian system, you install the Python 3 package, you get whatever Python is in that version of Debian, and that's it.
Yeah.
Unless you have some other like third-party package or something like this, and even then you're risking breaking your system and things. This is not all the way of you can have it any version you like with any dipping mustards that you like, because that's just probably not going to happen in this universe. But it's closer to that. Is the idea?
Pretty much.
I can say. And is it granular at the level of applications? Like an application can say, I want this Python version, but other applications on the system? Or is
no, it is still system level, and that's also one of like the downfalls of it, right? Is it's not actually composable.
Mm-hmm.
It's like vertically composable, sort of, but not fully, and it's horizontally composable, but in the bad ways. So it just makes for the system that is impracticable for anyone to actually work on. There's a whole graveyard of tools that Fedora has written, or Red Hat has written, to work with modularity and kind of mangle and tame the beast that they created.
And this goes back to your advice, I think, to it's okay to fail, and we will keep tilting at those windmills.
Yes.
Other questions? In the back there. Yeah.
To what extent are you paralleling work that the Red Hat people were going through, or it was different? How? In what way?
So there is probably a lot of rework, let's say, that's happening. The majority of the effort that we go into for rebuilding things is really just rebuilding. We go through a kind of continuous integration effort for rebuilding everything against CentOS Stream. So we're tracking not just the Red Hat releases, but also CentOS Stream, every commit in the Git there, and rebuilding those in separate projects so that we have the versions of that software available, basically as it would have been built in RHEL. So when there's a release of, yesterday was a good example because there were some updates for RHEL available. Like when there's updates available for that, oftentimes we'll already have the packages built and just need to sync them into the right repositories because they were built in CentOS Stream a few months ago. That's not always the case, like especially for vulnerabilities, where that's going to come right from Red Hat, and there's also discussion in the project about what's going on, how we might handle that. But
okay. You're sort of talking about the stuff you've got fairly well, you know how to handle, at least, even if it's like. But I meant, to what extent are you suffering the same headaches that Red Hat people are doing, and you don't know what to do yet when they don't know what to do, that kind of thing? Or are you free from some of the kinds of headaches because you've gone a different path from them, like that?
I think we have the same headaches in that the goal of Rocky Linux is to be 100% compatible with the upstream. So we don't really have any freedom or leeway, or haven't given ourselves any freedom or leeway to diverge from what exactly Red Hat is putting out, right? So the artifacts that we get from Red Hat, when they are a release from Red Hat, we know for some value of knowing that those have gone through QA and testing and have been validated to fix whatever it is that they say they're fixing. So we have to rebuild them. We have to strip the branding out and change some settings and features occasionally for build purposes, but largely we're able to abdicate a lot of that responsibility for testing to Red Hat and the work that's going on there. But also recognizing that you can't just ask someone to do something without giving back to it. And so that's why we focus on contributing to CentOS Stream and Fedora and the other kind of neighbors in that space, so that we are hopefully resolving our shared headaches before they actually become headaches. And that's, I think, what a lot of Red Hat has been trying to do with CentOS Stream in the past few years, even though it's not been communicated or taken very well in a lot of the community. The pathway to contribute to and make change in Red Hat and CentOS Stream exists in a way that it never had before.
I think we had another question here. Yeah.
I'm just curious, how is your community sizes? Because all the cool kids go into Kubernetes, and there is no really a need for updating the things because we just build new image from scratch every time and throw it over once. All this new distros, they super simple.
You always need somewhere to run the containers. There's a number of folks that are interested and or are running Rocky on containers. My employer, CIQ, is one of the primary, or one of the principal sponsors and such of Rocky. We have a customer that is running an kind of custom build of Rocky developed by CIQ for them to run container workloads on it specifically. And that work also is being upstreamed into Rocky in we have an OS tree SIG, if you're familiar with RPM OS tree. So we're doing some stuff with immutable desktops that Red Hat is also doing, but we are doing them in a little bit of a different way with how we've chosen to implement specific features of it. But
so you don't see any shrinkage in the community?
No, I don't think so. Our community, it's growing. It's hard to, I think, track rate of change and growth because there's people that come and leave, and we are largely like a volunteer-based organization. Like I said, I'm the only person that I know of that works full-time on Rocky, even
But you
partially.
Is it like CentOS refugees? Or is it...
I'd say a lot of CentOS refugees is probably primarily who it is, but it's also folks that are trying it for the first time or are learning about it in school. We've seen that coming out too. Like, that's one of the most insane things to me is like coming across job applications that say want Rocky Linux experience and stuff. And so it's still a little weird to be responsible for the stuff that comes out. So it is definitely being used. We hear when we break things, if we break them, but we very much try to stand by the principle of least astonishment, where we're trying to keep it as, if we make a decision, we're going to try and stick with that decision unless we have a really good reason to change, for technical purposes.
And it seems natural that sort of the CentOS, like the people who had the,
Yeah.
not to put too fine a point on it, but had the carpet yanked out from under them where they thought they had another 5 years, and actually those 5 years don't
Right.
exist. But there was something going on there, and Rocky is sort of carrying on that mission, I guess.
We're trying
in a
to.
way that CentOS Stream is not.
Yeah.
Is changing kind of that.
It is changing.
So the people who are interested in that, I think, still are, and that's, I think, where you're seeing people nucleating around that.
Yeah, I think that's a good way to put it, and it's also like the difference. One of the ways I like to describe the difference between CentOS Stream and what CentOS Linux had been is really just that it's the QA and testing that Red Hat does. Like, everything about Red Hat, all of the source code is in CentOS Stream. It's all there. The onus when you use CentOS Stream is then on you and your organization to essentially do a lot of the release engineering work that Red Hat does to distribute their operating system to their paying customers. Rocky and Alma and some others essentially are doing that work as well. It just happens to be that in Rocky's case, it looks a whole lot like we're taking the Red Hat sources and rebuilding them and distributing them, because we're just matching the versions in the software that they are. Reverse engineering is protected.
I think I saw another hand somewhere in the back, maybe? Please.
So I was wondering, well, I guess now I have two questions. I think the first one was sort of like, is there a process, if this is even the right way of thinking about it, is there a process for becoming like a CentOS, or excuse me, a Rocky Linux packager?
Yeah, so we don't really have packagers so much as we're not creating new packages for the most part. We do occasionally, but the majority of everything that we're building in the OS is a package that comes from Red Hat. So we don't really need to make changes to it other than potentially doing backporting or patchwork to swap out Red Hat for Rocky, or change out the images that are branded and copywritten by Red Hat. But we do also have special interest groups around the core of Rocky that do other interesting things, like OS tree, RPM OS tree is one I had mentioned. We have a kernel special interest group that their goal is going to be to work with EL repo, which is distributing long-term and mainline kernels rebuilt with the Red Hat config option set for use on Rocky systems. Like if you have I run a Rocky Linux desktop and have the 6.11 kernel on it from LRepo. But we want to be able to offer that in Rocky as a secure boot signed artifact, so users can keep secure boot on their system and some other stuff. We have a high performance computing special interest group that is some new work. We do have some new packages that come out of that. Recently, we've done some work with Intel to package up a Kmod for the Intel Arc graphics card drivers for HPC stuff. As I spill water. It's okay. We'll get it away from the electronics. Thank you. Yeah, we do a number of things in special interest groups that extend and may have new packages. Thank you. But for the most part, like being involved in Rocky and there's a matter most here, that's how we kind of contribute or communicate with each other. But it's less about like new packaging, and if packaging is what someone wants to do, we actually encourage people to go and contribute to EPEL and Fedora upstream, and kind of bring that back down into Rocky as it comes. That being said, we do use actively Rocky SIGs for the purpose of kind of testing some of that stuff out, like packages that aren't in Fedora that we may want to bring into them. I have personally used our build infrastructure to kind of do proof of concepts and build out the dependency chain that is going to be needed to prepare to go and build it in Fedora and get it released there, but have it in a place where the Rocky Linux users can just kind of use it as we're building out these things and not have to wait for getting it into Fedora, getting it into EPEL, having it all released out of there. So we don't want to do rework. We don't want to duplicate things that are already being done. We don't want to have a special interest group that just does exactly what CentOS has a special interest group that does. But we also really appreciate the ability to mutate Rocky in the way that we find useful.
We have time for one more.
So, kind of, you're touching it, but like earlier in the discussion or in the presentation, you're talking about like DNFs and stuff like that, and how like you don't want to necessarily copy what Fedora is doing, and that you guys are thinking about a little bit more.
Mm-hmm.
I was wondering if you could expand on more like the foundation of Rocky and how much of it can you do you think about so that you can pivot later on, or what stuff are
Sure.
you stuck with?
Yeah.
And that like that's it.
Right. So I think we are stuck with a lot of things, particularly the code that's coming from Red Hat. But we do have a lot of flexibility in the tooling that we use to build it. That's where we have created our build system called Paradot, which is it's our attempt to cloud native kind of the thing, and address a lot of perceived faults in the tooling of Fedora. We have a lot of leeway in that respect, because as long as we get out nominally the same product as Red Hat is producing, that's all really that we're looking to do. So if we build it in the same way with the same arguments and instructions, essentially, that Red Hat is releasing them with, then we are more or less certain to get the correct result, even if it is not fully reproducible. I think there was another part of your question I've forgotten.
Well, I guess he answered the part where it was like you can't. There's a lot of things that you're kind of stuck with, and you won't be able to pivot because of Red Hat.
Mm-hmm.
And then the other part was like I guess it's kind of similar. The past decision making. I think you kind of answered that.
Yeah.
I guess the foundation information, like what's the thought process of this?
Oh, right. The foundation. That's where I was trying to loop this back into. Thank you. The entire purpose of what we set out to try and do is to make it so that what we're doing can be done by anyone. The tooling and tribal knowledge required to compose Fedora today, even, is fairly tremendous. And it's a discussion point within the Fedora project itself of, we have all of these tools that we've written and work together in some form or fashion, usually just stitched together by a message bus, but they work. but could they work better, right? And so that's a discussion I think that's happening there as well, but it's something that Rocky was really founded upon because of what happened with CentOS and Red Hat and that just not being there. Like we want to make it, and part of this is the build system, is so that any person could take the build system and take RPMs that they are legally obligated to receive from Red Hat because they're a customer,